Okay, student, the next reaction is the Favorskii reaction, or we can say that the rearrangement. Let me first discuss some basic funda. For example, suppose methanol on react with the sodium. Methanol on react with the sodium. So it gives sodium methoxide plus H2 gas. If we are adding this sodium metal in any alcohol, it always generates the H2. Here, in case of the sodium methoxide, or in general we can say that sodium alkoxide, Ca3O minus and Na plus ionic form is exist. Ca3O minus and Na plus. So this one act as a base. In fact, sodium ethoxide is more basic than the NaOH. Sodium ethoxide is more basic than the NaOH. Now, as you know that we are considering NaOH is a strong base, but there are many strong bases in the NaOH. Sodium ethoxide act as a strong base. So, in Favorskii reaction, if we discuss the principal part, so in Favorskii reaction, it is the base catalyzed reaction. Base catalyzed reaction of, or we can say that base catalyzed rearrangement of alpha haloketones. Here, as a halogen, you can use chlorine or bromine. The base catalyzed rearrangement of alpha haloketone 2. Alpha haloketone 2 carboxylic acid derivatives. Carboxylic acid derivatives is known as Favorskii reaction, or we can say that Favorskii rearrangement. So your starting material is alpha haloketone and the final product is carboxylic acid derivatives, right? For example, if we take here CX, suppose this is R dash, this is R double dash, to differentiate the functionalities. So कार्बोनाइल कार्बन के पास में जो है वो अल्फा कार्बन है, सो वी कैन से दैट अल्फा हेलोकीटोन. अल्फा हेलोकीटोन इज कन्वर्टेड टू carboxylic acid derivative. So here C is attached with the R dash, R double dash, and these are transferred to here R group, and it is converted to R triple dash. Okay, this R triple dash comes from the here ONA, sodium alkoxide. So here this sodium alkoxide act as a base. That's why I am discussing this topic prior to this reaction. Clear? So here sodium alkoxide act as a base. You can use sodium methoxide, sodium ethoxide, sodium propoxide, anyone, right? Because they are act as a base. Clear? So here alpha haloketone converted to carboxylic acid derivatives. Okay, now we are discussing the mechanism part of Favorskii reaction. In mechanism, let me take one simple example. Suppose here is the R, one is H, alpha halo group is there. Suppose this is R and this is also R. So we can say that alpha haloketone. That means in Favorskii reaction, alpha haloketone is must. Okay. Suppose we react with the any sodium alkoxide group. So as we discussed that this sodium alkoxide group act as a base. So role of the base is to proton abstract the proton. So here proton is ready. Clear? So here hydrogen is H plus removed from the here. So one is here carbon is now negatively charged, which is attached with the 2R group. Chlorine is here and 2R group is also here. Now as we know that here donating part is there, here accepting part is also there, and removal part of is also there. So this negatively charged carbon attack over here, and chlorine as a leaving group leave from the molecule. So one functionality, this R attached with, this carbon attached with this carbon. Now between these two carbon, one carbonyl group is there. This carbon contain 2R group. Same, this carbon also contain 2R group. So this is the intermediate cyclic ketone. 3-member cyclic ketone is the intermediate. Again we have the R double dash O minus part, and now it is act as a nucleophile. Here R O minus act as a base to abstract this proton, and now in this step it act as a nucleophile. Why nucleophile? Because here carbonyl carbon is there, 3-member ring is also there. Now as you know that in 3-member ring more strain exists, that's why it can easily break down, because 3-member ring is less stable. We can say that more strain, that's why easily break. So this negative charge attack on this carbonyl carbon, and now this this oxygen attract the bonding electron pair. So the intermediate is here O minus. Why? It attract the bonding electron pair. Addition of OR double dash minus this carbon attached with the 2R group. This carbon also attached with the 2R group, right? So now as we know that 3-member ring is more strain, that's why this oxygen again participate in the bonding, and this carbon attract the bonding electron pair toward itself. So the product is this carbon attached with 2R group. Now this carbon attached with this carbon here, this carbon attached with doubly bonded O, and this carbon also attached with the OR double dash. So the ester functionalities exist. This one is minus charge. Now to stabilize the minus charge we have to add some H plus. कहाँ से आएगा H plus? अल्कोहल में से. ये अल्कोहल कहाँ से आया? So here OR minus, H plus from here. So here removal of R double dash OH. RO minus, उसने क्या किया? प्रोटॉन एब्स्ट्रैक्ट किया. So R double dash OH. Alcohol is the proton, and as we know that the alcohol act as a good proton donor. So it donate here H plus. So RO minus वापस मिल गया. ठीक है. So now the product is here R C double O R double dash, here CH, which contain 2 R groups. So we can say that the carboxylic acid derivatives is formed in Favorskii reaction. Clear? So in the first step, abstract the proton by the sodium alkoxide, right? After that, this anion attack with the nearer carbon to remove the leaving group, means halogen. It gives cyclic 3-member carbonyl group, which is more strain. That's why now OR minus act as a nucleophile, and it remove the strain by opening the ring. And the later on addition of proton. Clear? So in short, we can say that out of these 3 carbon, 1 carbon is converted to COO, or we can say the carboxylic acid derivatives part. Out of these 3 carbon, 1 carbon is converted to carboxylic acid derivatives part. Okay, now let me discuss some application part. Suppose we are starting with this one, cyclobutane derivatives. So first of all, we have to think that the Favorskii is possible or not. So starting material is alpha halo ketone. So Favorskii is possible. If यहाँ पे आपको COO माइनस CH2O माइनस एंड Na प्लस दिया हुआ है, मीन्स बेस है, अल्फा हेलो कीटोन भी है, मीन्स Favorskii इज पॉसिबल. ओके, हमने क्या डिस्कस किया? जो कार्बोनाइल वाला कार्बन है वो कार्बोक्सिलिक एसिड में कन्वर्ट होगा. that means 1 to 3 carbon is also here, so it is now converted to 1 to 3 carbon, and this carbon is converted to COO C2H5. Why C2H5? Because here we are adding the sodium ethoxide, so this is the product. Let me take one more example. चलो अल्फा हेलो एस्टर है इसमें, सॉरी अल्फा हेलो कीटोन है इसमें. सपोज वी आर एडिंग दी CH3O minus Na+ सोडियम मिथॉक्साइड. सो फर्स्ट वन इट एब्स्ट्रैक्ट द प्रोटॉन. कहाँ से करेगा? यहाँ से. सो दिस इज नेगेटिवली चार्ज. दिस नेगेटिव चार्ज अटैक हियर, ब्रोमीन रिमूव. सो आई एम शोविंग दी डायरेक्टली दी intermediate. This carbon attached with this one, this carbon attached with this carbon. Between these two carbon, one carbonyl is there. This carbon attached with 1H 1Br. 2H में से एक तो abstract हो गया, so 1H is remain and 1 bromine. This carbon attached with 2 methyl group. Clear? Now this one act as a nucleophile. That's why this attack over this carbonyl carbon. This bond transfer to here. So one more functionality is there. Here O minus, here OCH3, here H, here Br. 2 methyl group is there. Okay. Important thing is here. In general, this bond transfer to here, this bond transfer to this carbon, right? This carbon. But as you know that here, instead of carbon removal, here bromine is also there. So when you are transfer bond here, when you are transferring the bond here, so here bromine is removed as a leaving group. Clear? So bromine is removed as a removing group. So the final product is CH3, which is attached with this carbon. This carbon contain COO CH3 part, right? And this carbon attached with the here H, CH, and this one is the negatively charged. Clear? Is it so? चलो अब लास्ट में हमने क्या किया था? एडिशन ऑफ H+, तो एक में कन्वर्ट हो गया CH2 में. लेकिन अगर हम इसको CH2 में भी कन्वर्ट करते हैं फिर भी इसकी वैलेंसी कंप्लीट नहीं हो. दैट मीन्स दिस वन इज नॉट पॉसिबल. सो व्हाट हैपन when this bond transfer to here, so instead of breaking this bond, now we are breaking this bond in this way. So this bond transfer from this carbon to here. So instead of here single bond, it is now converted to double bond. Why it is double bond? Because आपको ये living group मिल रहा है यहाँ पे. So this oxygen negatively charged participate in the bonding. This bond transfer to here. This means carbon-carbon double bond is formed, and bromine as a leaving group leave from the molecule. So here 2 methyl group, here carbon-carbon double bond, and this carbon here CH is attached with the COO CH3, and this one is your product. Clear? So if 2 living group is there, आपको पता है कि अगर लिविंग ग्रुप मिल रहा है तो उसको लीव करना ही है. अगर ड्यूरिंग मैकेनिज्म आपको लिविंग ग्रुप मिल रहा है तो उसको निकालना है. तो इसको हम निकालेंगे तो ऐसी प्रोडक्ट है, अगर नहीं निकालेंगे तो यहाँ तक चलेगा. सो ये तो स्टेबल होगी नहीं क्योंकि यहाँ पे कार्बन की वैलेंसी कंप्लीट नहीं हो रही है. दैट मीन्स ए वाली प्रोडक्ट इज द फाइनल प्रोडक्ट. ओके, लेट वी टेक वन मोर एग्जांपल बिकॉज दिस वन इज द इम्पोर्टेंट रिएक्शन. सपोज साइक्लोहेक्सोनोन है, फर्स्ट हम उसका ब्रोमिनेशन करवाते हैं. तो क्या होगा? ऑर्थो पोजिशन, वी कैन नॉट से ऑर्थो, लेकिन दिस वन इज द सेकंड पोजिशन 1 and 2. सो हियर सेकंड पोजिशन इज ब्रोमिनेटिंग. सपोज नाउ इट रिएक्ट विद द NaOMe, सोडियम मिथॉक्साइड. सो इन केस ऑफ द फेवरस्की रिएक्शन, फर्स्ट एब्स्ट्रैक्शन ऑफ प्रोटॉन. सो दिस प्रोटॉन इज हाईली एसिडिक क्योंकि पास में कार्बोनाइल ग्रुप है ना, तो यहाँ से इलेक्ट्रॉन अट्रैक्ट करेगा. दैट मीन्स दिस हाइड्रोजन रिमूव एज ए H+ वेरी इजीली. आपके पास यहाँ पे भी है, यहाँ पे भी है, यहाँ पे H+ है, लेकिन रिमूव कौन सा वाला होगा? ए वाला. क्यों? क्योंकि पास में कार्बोनाइल ग्रुप है, उसकी इलेक्ट्रॉन विड्रॉइंग इफेक्ट लगेगी. दैट्स वाई हियर carbon is negatively charged, here is the bromine. So as per the mechanism, this negatively charged attack over here, bromine as a living group leave from the molecule. So here carbon carbon double bond is formed, कार्बोनाइल एज इट इज, ब्रोमीन निकल गया. चलो अब ए वाला जो है यहाँ पे उसने बेस का काम किया, अब ए वाला यहाँ पे न्यूक्लियोफाइल का काम करेगा. सो दिस वन अटैक ओवर हियर, दिस बॉन्ड ट्रांसफर टू ऑक्सीजन, हियर O माइनस एंड हियर OMe. क्लियर यहाँ तक? ओके, अब क्या होगा, ए वाला बॉन्ड अगेन पार्टिसिपेट इन दी बॉन्डिंग, अगेन पार्टिसिपेट इन दी बॉन्डिंग, और आउट ऑफ दिस टू बॉन्ड, ये सेम ही है ना, इसको यहाँ पे लगा हो या इसको यहाँ पे लगा, उससे कोई फर्क नहीं पड़ने वाला. सपोज दिस बॉन्ड ट्रांसफर टू हियर, सो हियर ए बॉन्ड तो ब्रेक कर दिया हमने, मीन्स पीछे क्या रहा, ए और ए वाला बॉन्ड, मीन्स साइक्लो पेंटेन पार्ट पीछे रही. चलो ये तो ए बॉन्ड तो ब्रेक हो गया, दैट मीन्स यहाँ पे नेगेटिवली चार्ज. इसके पास क्या आ गया, C डबल बॉन्ड OMe. लास्ट स्टेप में क्या था, एडिशन ऑफ अल्कोहल, सो इट गिव्स दी H प्लस. अल्कोहल क्या रहेगा यहाँ पे, CH3OH, क्योंकि यहाँ पे OMe प्लस H प्लस. सो हियर रिमूवल ऑफ CH3OH विच इज नाउ हियर एक्ट एज अ प्रोटॉन डोनर. And this one is the final product. Clear? So one hydrogen comes from the here. Clear? So here 6 member ring is converted to 5 member ring because हमने mechanism में discuss किया कि 1 carbonyl is converted to carboxylic acid derivatives part. Clear? So this is the Favorskii reaction.